Greetings. Welcome to presentation 1.1, The Design Professional. Topics that are going to be covered include the role of the design professional, zoning ordinances, building codes, standard setting agencies, and the master format. When I come across videos that I think are interesting, I'd like to share them with you. This one, created by the AIA, that's the American Institute of Architects, What Architects Do. Very good video. I forget, 6-7 minutes. I'm not going to show you anything from it, and I wouldn't say that anything on it is test worthy. If it ever is, I would be more specific about what I thought was so great. But just in general, very good, informative video, telling about the life of an architect, kind of, so to speak. Worth checking out if you're interested. So the role of the design professional. So I looked at a couple of different team charts, just images right off the web, not specific to anything, because what I wanted to do was define exactly who the design professionals could be on a project in our business. And these charts, I thought, kind of put a nice visual to it. So here we see an owner, and who's the design professional? It could be anyone over here, I would say, architect, landscape architect, engineers, and then over here, this chart, which I know nothing about, is also showing that the owner is has a contract with the civil engineer separately, and that could be the case. Typically, the architect will hire and manage the engineers, but often the civil engineer will come in early, looking at the site, obviously, and consulting directly with the owner. So also design professionals, engineer, and then working with the engineer, we see a surveyor and an environmental engineer as well. So here I would say 6 design professionals. Another one I saw, and again, I know nothing about it, but I just want to take a quick look and just point out who I would say are the design professionals in this group. So this looks like not a team organization, but a company organization. So up here we have the big wigs at the top, and here in the middle we have operational support, and then over here there's the design team, the design leg of this operation. So we have a manager, and right across the bottom here, all design professionals, in my opinion. So structural or civil engineer, and that's abbreviated SE or CE, and I will use these abbreviations throughout the term, so worth talking about here. Mechanical engineer, ME. So the ME is responsible for the air conditioning, the heating, energy. The EE, the electrical engineer and communications, takes care of all your electrical. Communications would be low voltage. Environmental engineer, the architect, the interior designer, the landscape designer, and drafting. So all design professionals in our business. All right, over here's the construction leg of this firm. So not the design professionals, but anybody in these professions. And typically our architects are registered architects, so professionally licensed, and our engineers are PEs, professional engineers. So that's typically who the design professionals are, the licensed professionals. All right, moving on. So this is the next few slides are going to talk more specifically about architects, but as I just said, that is not the only design professional on the team by any means. So architects are licensed or registered in the jurisdiction where they have to work. Same with engineers. They hold professional degrees, internships. Architects specifically take the ARE, and engineers have their equivalent exam as well, and they are involved in continuing ed as they go. In practice, what architects do, so a commission given by a client could be any number of behind-the-scene tasks beforehand, before or in addition to designing buildings. So feasibility studies, just to see if an idea is going to work. Building audits, there are several different types of audits. Could be for existing buildings. The design of buildings, of course, and structures and interior spaces. Programming, architects need to figure out exactly what their clients' needs are, and then put that into a written format so that it's understood, and that's what the design is based on. But just figuring out what's needed exactly. Some owners are experts themselves. Institutional clients know what they need and could present that to the architect often, but first-time home owners or home builders, home buyers, I guess, designing a house from scratch would have no idea what they needed exactly. They, in a bigger, vaguer term, yes, but specific requirements, square footage, often the architects will have to work through that with their clients. In general, the architect coordinates the design team. Typically, the engineers will be hired by the architect. Not always the case. Some design build operations, we could see general contractors being at the top of the team, and then the architects are hired by them actually. And some teams, depending on the project type, could also be engineer-led. So a variety of options. For what we're dealing with, residences and commercial buildings, typically architect lead. So here are other engineers who work with the architect. And in general, it's this team, the architect and the engineers, that are responsible for the selection of materials and systems, which is what we will be studying this term, obviously. Moving on. So in general, the design professionals, architects and engineers, need to navigate the local and federal jurisdictions and interface with people in the zoning departments and the license and inspection departments. These are the people that give out the building permits and will inspect the work as it goes and then certify that it's up to code and is habitable. Not until these people sign off on everything, it can't be occupied by the owner, who is typically the architects and engineers' client. So architects and engineers are hired for their expertise in dealing with the municipalities in this regard. So regulations and building codes. So a number of things fall into this. Right now they're bunched up here, and we're going to break them out from zoning to building codes shortly. So setbacks, how far something needs to be from its property line, how tall it could be, how much parking is required, the amount of window required, and land use, just are you allowed to build that type of building in this location? Big first question. And then there's often a whole nother layer of requirements that need to be addressed. Could be historic preservation guidelines. These are just a few of many, many. During construction, the architects and engineers will often advise on the award. So the architects and engineers have created the bid documents, which take the form of drawings, construction drawings, and that will be supplemented sometimes with the specifications, and that will be given out by the owner or put out for bid, and the bids will come in, and the design team could advise on the award of the bid. They will review the progress of work during construction. Yes, they don't supervise the construction, but they could review the progress for the owner. If it's a large job and there's shop drawings and submittals created by the contractor, then the architect and engineering team would review those and say, yes, these shop drawings look good. The architect would have drawn maybe some cabinetry, but then the cabinet maker would make the actual shop drawings from which they're being built, and the architect will review that and say, yes, you understood my intent. These are satisfactory, or we need to make some modifications. And then the architect engineering team will also stay involved with construction administration. So they will oversee the basically the issues that need to be addressed in the contract, including payment, where they will review the progress, and they will say to the client, yes, the builder has completed 80% of the concrete work. They've completed 20% of the walls, and that's what they should be paid for to date. So they could be very much involved after the fact. Don't have to be, not necessarily involved with construction, but could be, remain very involved. Again, maybe smaller projects, less involved. More complex projects, they stay involved for the owner and represent the owner. All right, moving on to zoning ordinances. Okay, so this is big picture, site level issues that the architects and engineers need to work through before designing actual buildings. So this is land use we're referring to. So what types of activities are actually allowed on this property? Residential, commercial, industrial. So all of this exists in zoning maps that the municipalities own and or hold, and architects and engineers need to make that determination. Given the size of the property, given its location, how much of it is actually by a percentage, what percentage could actually be covered in building? How far does the building need to be kept off of neighboring property lines? What are the parking requirements? How big in terms of square footage and height can the building be? And are there special fire district requirements as well? So big picture site issues. Civil engineers would be involved with this. Architects would be maybe not doing the research, but definitely communicating with the architects, communicating with the engineers and learning essentially from them what's possible, and then trying to see if they could work a building inside of that envelope and help determine with them if this is feasible. Can we fit the building we need with the parking we need on the site that we have? Okay, on to building codes, different department. So here in general, building codes, the purpose is to specify the minimum standards for construction of buildings, right? So they are not legally binding as they stand, a building code per se. They become law when a jurisdiction formally adapts them. And we'll talk in a moment about model building codes. But a building code by itself is a third-party creation. The municipality will adapt it, and then it becomes an ordinance within that municipality. And they could adapt the building codes wholeheartedly and just take it all. We accept the 2014 version of that code and we'll make it our own, or they could modify it and say, and publish a kind of an addendum to it and say, we want these parts of the code to be more stringent, or we want to not have these parts of the code in ours at all. So that could go in either direction. General purposes to protect the public health, safety, and general welfare of the people, of the occupants of the structure. Okay, there are many different building codes. Model building codes are really what I just described. So they're standardized codes, and they are adopted by jurisdictions or not, in full or in some capacity. The two big ones that we are concerned with most for general construction is the International Building Code. So this applies to all building types except those covered in the International Residential Code, which covers 1- and 2-family houses, townhouses, and those types of houses up to a 3-story max. So these homes fall in the IRC. Anything that's not in the IRC is therefore in the IBC. Then our engineers would be concerned with the more specific codes that apply to their fields. And then here on the right, these massive code books include several different things. So building code occupancy classifications, these first three we're going to take a closer look at. Construction types, building heights and areas, numerous other pieces, a lot of information. It's a great niche to have, to be a code person in your office, to really understand this, and you're a very valued team member. It's fair to say that. Okay, so we're going to run through a couple of the parts now that we find in the code book. All right, so first are the IBC occupancy groups. All right, so this is the IBC, referring right here to the International Building Code. So they impose this structure over all building types, and they define first things first is to figure out what type of building we're dealing with, and then we'll go in further detail as to what can and cannot happen, what is required of that building type. So here are the different building types. So there's type A, type B, type E, and you could see, I'm not going to read them all off to you, but every building type falls somewhere in here. And many building types have more than one occupancy group. So a shopping mall could have a theater in it, which could be an assembly area, and then it could also have shopping here. So it gets very complex. It could be very complex. Moving on. So here are some examples, just a little more detail about two particular occupancy groups. So definitions reflect the relative safety concerns of different types of activity. So it's all about safety here. So occupancy group A is assembly. It includes theaters, auditoriums, lecture halls, nightclubs, and other places where the public will gather. Here, in these types of spaces, large crowds in unfamiliar settings need special attention to emergency exit provisions. All right, so there have been some tragedies in nightclubs, in particular, dealing with fires or shootings. The whole issue of this building code exercise is to make these buildings safe. When the worst thing happens, how do these people get out safely? That is, in short, the heart of the matter for building codes. Another one here, occupancy group I, for institutional, hospitals, prisons, other facilities where occupants cannot fend for themselves in an emergency. So during an emergency, these occupants cannot exit the facility by themselves, so they have to be provided with a protected area within the building. So in any building really with a fire stairwell, if there's a fire, the elevators don't work, people in wheelchairs must be provided with room inside the stairwell, and they cannot be in the way of people exiting through the stairwell, but they must be provided safe space for themselves to wait until help arrives to get them down the stairwell. So that's called an area of refuge. All right, so these are just two little more detail examples of the great attention to detail and requirements that is required of building codes. Okay, moving on. Okay, excuse me. So now construction types, a different issue within, or a different structure that's applied to buildings within the IBC. All right, so they define buildings construction type relative to varying degrees of fire resistance. Okay, so here is type 5, so this is combustible. So this is wood frame construction. This is the least fire resistant. Top 5 is type 5. Getting better than that is type 4, heavy timber construction. So not small dimensional 2x lumber, but heavy timbers. It doesn't burn as quickly. It chars and it doesn't burn, so it's better. So it's type 4. If there's a non-combustible exterior, stone, brick, now you're moving into type 3. Non-combustible exterior and other components, type 2. This is broken down in a ton of detail within the codes, but we're just going to keep it simple and just review here. Type 1 is the non-combustible materials, and the structure is non-combustible as well. All right, so those are the 5 types, the 5 levels, 5 types of construction, and they are associated with the 5 levels of fire resistance. All right, so what do we do with that information? We come here and we could figure out exactly how big of a building we're allowed to make after we've established our group type here on the left and our construction type here on the x-axis running across the top. Okay, so we've established that we have an assembly, an A1. There are actually 5 different types of assemblies. So on my previous slide, I just showed A as assembly. There are 5 different types. They'll cover everything from bleachers at an amusement park up to an arena. 5 different levels of assembly. So here we are with A1 assembly. And then here we have our construction types. Type 1, this is the most fire resistant, down to the least fire resistant. S here for our chart is stories above grade. How tall can the building be? A here is building area per story. So how many square feet are we allowed to have on each floor? All right. If we start with the least fire resistant assembly, we can have a single story above grade. So just one story. And that story can be 5,500 square feet. All right, so this is type 5, least fire resistant type of construction, type B. So again, each of these is broken out into type A and type B. So type A is more fire resistant than type B. So type B is at the very bottom. So my assembly building could be one big floor. Okay, now if my client says that's just not going to do, then we're going to have to invest more money into a more expensive, more fire resistant construction type. And that might get us up to type 3. Let's see what we could have there. If we jumped up to type 3A. So here I am, there's my assembly, type 3A. I could have 3 floors, and they are 14,000 square feet per story. So big improvement. And then it goes all the way up to unlimited. These aren't the only matters that are going to dictate how large of a building you can make. There's zoning is on top of that. There are other layers. But in terms of the building type construction, we could say that it's unlimited. All right. So it's not being limited by the type of construction, the physical materials that are making it up. Okay, so you should be able to understand this chart. It's covered well in the textbook, so read through this part slowly and understand how to work your way through here. All right. Okay, so after we've established something in the chart, we've come to somewhat of a conclusion. Now there are possibilities for modification. So this is just another level of complexity. And I'm just going to mention these briefly. We're not going to have examples or jump too deep into this at all. But you should be aware of it. You should also be getting a sense of the complexity of codes and the necessary training to really navigate this world. Okay, so we've established something here on our chart. We've established something here, a height and a square footage, and now we want to make some modifications to it. We want to improve it. So providing greater firefighter access around the building, getting trucks around the building, that improves things, increases the building size. Increasing the building height, however, will make a reduction of floor area, so something else that would be considered. Fire sprinklers, historically proven to be a big benefit. Adding sprinklers allows for a 400% increase to an allowable area for one story and 300 in another scenario. Not concerned about the details here. There are many layers of details, just to give you a sense as to how conclusions are adjusted. All very much by the book. It's really not negotiable. It's very black and white in the code book what can and cannot happen. But there are many layers to it. Suffice to say that. And here, this last bullet is important. The presence of sprinkler systems provides many other bonuses in other parts of the code. So here we are just at the very beginning of this 900 page code book, and all we're trying to do is figure out how big of a building we can make, how tall and how wide. There are many more chapters coming down the line concerning floors and construction of walls, and if these sprinklers are in place already, we've committed to them, there will be more benefits to be had later while we work through other additional tables. And I'm saying us, we're not going to do it in this class. This is really all we're going to touch on in terms of code. But just so that you know that a full code review is a lengthy process where you move from chapter to chapter, and the sprinkler systems help. Okay, other design constraints. So that is our code that we get from the municipality, and then there are other layers. Excuse me. Other layers. So accessibility. This is a federal law, the ADA, the Americans with Disabilities Act. So a federal law that's non-negotiable. That if you're doing commercial buildings, you will know it, and you will design to meet that. OSHA, very important as well. So this is all things safety. OSHA, environmental regulations, and then building insurance could also have layers put upon. In order to get insurance, certain things have to be met, certain standards have to be met. So other design constraints that the design team has to work with from the beginning. All right. So some standard setting agencies. So these are third parties that are developed that work outside of our on the outside of our business essentially, and they create they create standards that we agree to and live with. So there are a couple I'll just mention quickly. Here's the Underwriters Lab, the UL, and then we also have ANSI, another very important one I'm sure you've come across. And these extend outside of building. They all manufactured products they cover. And then we have our building codes, and some also exist for accessible standards and green building standards. So all third parties that live outside, they work independently, and then municipalities or groups will adapt the work that they've done, essentially. The UL one here, the Underwriters Laboratory, I just want to mention, say a few things about. It's definitely something a designer would become acquainted with quickly in an office. So they test everything. So manufacturers will come to them to have their assemblies tested. So again, a product is drywall, a product is a steel stud, a product is insulation. When they come together, they form an assembly. The manufacturers will prove to themselves first that this assembly will be a 1-hour fire-rated assembly. Then they will pay the people at the Underwriters Lab money to build and test this assembly, to light it on fire and test it. And then when it is in fact proved by them, the third-party people, that it is that 1-hour rated, then it will go into the UL book. So as an architect, we spend a lot of time looking at these. When we when we learn from code that we need a 2-hour fire-rated wall at a certain location, we will go to the UL book and we will find that assembly. So we are not designing things from scratch. We're not trying to prove anything. The good folks at UL have already proved it. They've built this thing, they've burned it, they've tested it, they've proved it, and this is a huge resource. And we will put this in our construction documents and say to our builders, this must be a UL U465 wall. Okay. Moving on. And now we will talk about the master format. I think this is the last piece of our lecture here. A few more slides. The master format. So a master list of 50 divisions. All right, so this is basically a big index of all of the materials that we're going to be studying. They live somewhere in this index, and this index allows the designers to communicate clearly with the builders, who communicate clearly with the manufacturers. Everybody involved needs to know where that particular piece of hardware lives. It needs a description in the index so that we all know where to classify it and where to categorize it in whichever documents we're creating or reading. So it's a list of 50 divisions. Divisions have section numbers and titles. To organize information about the construction pieces, all the sticks and the bricks that go in the building, everything that makes it up has a place in this master format. So we organize information into distinct groups, and we make the location of it consistent. So we are not going to use this for this class, in that I'm not going to refer to the division that it falls in. Rarely would I. But in professional practice, on the design side, the construction side, anywhere you live in this business, you will need to know this. So it is imperative. So it provides an outline for construction specifications. That's the written portion of the documents. So we have the drawings and we have the specifications. The specs are organized per the master format. All cost data could be organized per the master format, and the people that provide our technical literature, the manufacturers of all the different components that are going in, they will organize it as such as well. So in order to communicate with them, we need to understand and be on the same page. Here is a look at it. So again, there are 50 of them. These are the divisions most relevant to this text and building construction in general. There are other divisions that include things like infrastructure or process equipment. We're just concerned with buildings, residential buildings up through high rises. So these are the divisions that we need. So you could say they're quite straightforward, but when you want to go talk to your window representative, you need to know that those windows exist in Division 8 openings. That's where their information in an index, in a catalog of many manufacturers, that is where you would find it. Okay, this just will quickly show us how deep these many divisions go. Okay, so here are the divisions again, 2 through 14, then we'll skip a couple. So we have concrete, metals, woods. Here we're getting more into equipment. Conveying equipment would be our elevators and escalators. And then we get into our engineers here, mechanical, electrical, plumbing, communications, and then out here we have some exterior work. Okay, just a quick review of them, and then those break down and break down and break down further. So we have Division 5, metals. Then we have 0510, structural steel framing. 0521, steel joist framing. And then we break it down further. 0550 is metal fabrications. 0551, 33, metal ladders. And then even on top of that, we'll add point 13 and we'll find vertical metal ladders. So it's everything has a home and it's buried in there, but there's a logic to it, and once you become familiar with it, it's very easy. It makes life manageable. So buried inside of metals, vertical metal ladders. All right, and that is the final slide. So thank you for your attention to that. I know it's a lot of information. I know it's text heavy. Fortunately for everybody moving forward after this week, we'll be looking at a lot more images, as I discussed in the introductory video, drawings and photographs of buildings. You know, that's really the heart of the matter, but this background is super important. So I hope you enjoyed this one. Next, we're going to move on to the construction professional and what life looks like from their vantage point. Thank you.